Hi there and welcome back to the ML Trainer. Today we're going through some common interview questions related to decision trees. If you haven't watched it yet, I'd recommend starting with this video, where I go through decision trees in detail and walk through the ID3 algorithm step by step. If you're ready to dive into some interview questions, let's get started. I've split up the questions into 3 levels: basic, intermediate, and advanced. Let's start with some basic questions. If you found this content useful, be sure to like the video and subscribe to the channel to stay up to date with the latest ML interview prep content. Let's start with something simple. What is a decision tree? A decision tree is a supervised learning algorithm that can be used for both classification and regression tasks. It works by recursively splitting the dataset based on features, creating a tree-like structure where internal nodes represent features being used for the split, branches represent the conditions for each split, and leaf nodes represent the final predictions or decisions. Next, what are the main advantages and disadvantages of using decision trees? Some advantages are that it is easy to understand and interpret, it can handle both numerical and categorical data, and it requires little data preparation. You don't really have to use feature scaling or normalization to use decision trees. Some disadvantages include the fact that decision trees are prone to overfitting. They can create overly complex trees that don't generalize well. They can also be unstable. Small variations in data may result in completely different trees. The greedy algorithms used for tree construction may also not result in the globally optimal tree. Next, explain the concepts of entropy and information gain in the context of decision trees. Entropy is a measure of uncertainty in a dataset. In decision trees, it's used to quantify the randomness in the data at each node. Information gain is the decrease in entropy after a dataset is split on an attribute, or feature. It's used to decide which feature to split on at each step in building the tree. The attribute or feature with the highest information gain is chosen for the split, as it provides the most information about the classification. Next, let's move on to some intermediate questions. What are some ways to improve the performance of decision trees? There are several techniques that we can use to improve the performance of decision trees. One of them is pruning. We can use pre-pruning and post-pruning to either stop growing the tree early by using some criteria like max depth, or to remove nodes that don't improve the tree's overall performance. We can also use ensemble methods like random forests or gradient boosting to build multiple trees and aggregate their predictions, and this can improve robustness, generalization, and accuracy. Finally, we can use cross-validation. Splitting the dataset into multiple folds can aid us in understanding generalization errors and assessing the tree's performance on unseen data. Next, what's the difference between classification and regression trees? While both use similar algorithms to construct the tree, they differ in their output. Classification trees are used for categorical outputs. They predict the class or category of a sample. Regression trees, on the other hand, are used for continuous outputs. They predict a real number value. One key difference is in how they choose features to split on. Classification trees pick features that maximize information gain, while regression trees pick features that minimize mean-squared error or variance in the prediction. Another key difference is in how the values at leaf nodes are determined. Classification trees use majority vote, or probability, while regression trees use the average of the samples in the leaf. Next question. How do decision trees handle missing data? There are several strategies that can be used. First, imputation. In imputation, missing values can be filled using methods like the mean, median, or using clustering methods like k-nearest neighbors before training. Surrogate splits. In surrogate splits, the tree finds another feature, or a surrogate, to split on when the data is missing for the primary feature. Next, assigning to multiple branches. The algorithm may send samples with missing values in a particular feature to both child nodes, based on a probabilistic approach, for example, where the probability of falling into each node is proportional to the impurity or information gain of that node. Treating missing as a category. Missing values can be treated as a separate category for categorical features. And finally, pruning. Pruning helps reduce overfitting and the impact of missing data. Next, what is a random forest and how is it an extension of decision trees? Random forests are an ensemble learning method that combines multiple decision trees to improve predictive accuracy and control overfitting. Random forests build a forest of decision trees, typically trained on various subsets of the training data. This technique is known as bagging. During the training of each tree, the algorithm randomly selects a subset of data points with replacement and a subset of features. This randomness helps to create diverse trees. For classification tasks, each tree makes a prediction, and the final output is determined by majority voting amongst all the trees. For regression tasks, the average of the predictions is taken. Let's move on to some advanced topics. How do you handle high-dimensional data when building decision trees? There are several strategies that you can take. First, feature selection. You can identify the most relevant features and train only with the top subset of the features. You can also use dimensionality reduction techniques like principal component analysis to project the data into a lower dimensional space. Finally, you can also use ensemble methods like random forests to combine multiple trees trained on different subsets of features. Next, explain how you would use decision trees for feature selection in a dataset with a large number of features. Decision trees use measures like information gain or Gini impurity to determine which feature should be selected first to split the data on. This is intrinsically a measure of how important a feature is. To use decision trees for feature selection in a dataset with many features, train a decision tree model and then analyze the feature importance scores generated by the model. Features with high importance scores would be retained for further analysis or modeling, while those with low scores could be discarded to reduce dimensionality and improve model performance. Next question. What is the inductive bias of decision trees? An inductive bias is a set of assumptions that a machine learning algorithm uses to make predictions about new data based on what it learned from training data. It influences how it selects a hypothesis, which is a possible explanation or model, from the hypothesis space, which is a set of all possible hypotheses, that best fits the training data. The inductive bias of decision trees is the preference for shorter trees with fewer splits, and for the trees that place features with high information gain close to the root. And here's the last question. Explain the bias-variance trade-off in the context of decision trees. Bias refers to the error due to overly simplistic assumptions in the model, leading to underfitting. In decision trees, a shallow tree might have high bias and fails to capture complex patterns in the data. Variance refers to the error caused by sensitivity to fluctuations in the training data, leading to overfitting. A deep decision tree has high variance and could perfectly fit the training data, including its noise, but performs poorly on unseen data. As you increase the complexity of a decision tree by increasing the number of splits, bias decreases but variance increases. Conversely, simplifying the tree increases bias but decreases variance. The goal is to find a balance that minimizes total error, and this is often achieved through techniques like pruning and hyperparameter tuning. That's all we have for today. Thanks for watching the ML Trainer. If you found this video useful, please consider liking and subscribing. If there's any particular topic you'd like me to cover next, feel free to leave a comment below.